we can see.
Yeah. So what I have in my hand is a pen. I'm using a Surface Pro 3, and our app shows, the main view of our app looks like paper and pencil. It's graph paper here, and I can write on it. So if I start writing some numbers, this is what happens. There's some visual cues that show up. First of all, my handwriting doesn't change, but this blue typeset below it is the computer telling me what it thinks I wrote. Okay? If I want to change this, I can scribble out the parts I don't want, and then maybe I'll write a 2 that's a little higher than a 3, which in standard math notation means exponent. So I've written 3 squared. Okay? So the first thing you should know is that anything you can write, and this is our goal, there are some pointers or areas of math we don't support yet, but anything you could write on paper, or anything you would read in a book that's in the standard math notation format that's evolved over thousands of years for a good reason, you could use as the way to tell the computer what math you're talking about or what you're thinking. Okay, so what can you do if you can do that? This arrow we call the single arrow, and it means simplify whatever's on the left. So this is taking 3 squared plus 2 and simplifying it. That's 9 plus 2 is 11. If I, just to show how this works, if I write 3 nines and I have a single arrow, the result on the right is 1/3. If I write 3 nines and I do a second type of arrow, which is our evaluation operator, it means give me a decimal approximation of that, of whatever's on the left. So now it's not, the simplify always gives you an equivalent answer, maybe in a smaller or simpler form, whereas the one here on the right is giving me a decimal approximation that's not necessarily equal to whatever's on the left. Okay?
Are you changing the color of your
Go
pen
ahead.
there?
Any questions?
Are you changing the color of your pen there, or does it do it automatically when you have like a division thing? It changed colors of the pen? Like if you did 3 divided by 2, the numerator would be in red and the denominator would be in black. Did you do that, or was that the program?
I'm having trouble hearing you, but are you saying can I change the color of the pen?
No,
No,
what
go ahead.
was the pen, were you changing the pen color, or was that doing it automatically in the program when you were writing fractions?
It's changing, that's changing in the program because it was meant to sort of semantically tell you it thinks that's a numerator or a denominator. It's on a different line than the sort of root line of the math.
Got it.
So if I move 2 over 3, this is something that, so the 2 is a different color up top because it means it's a numerator. And if I write x squared, the blue means just it thinks it's on the exponent line. And then
Thanks.
if I move down, it will change to black. And then if it's a subscript, it'll be another color.
Thank you.
Yeah. Okay. So moving on. See here. I'm going to go back to the outline here. So graphing and sliders. Again, we're going to just move quickly here. My computer is okay. Let's say I want to graph something. I can write the thing I want to graph, and then on the side I draw one way to do it is to draw an empty graph. And aside from just writing that, we have marks that mean that we call gestures, and it's for a command. So I'll do that again. If I want to get at a graph, I just draw a large coordinate axis, and it gets replaced with a widget that looks good. It would take me a while to draw this widget, or to get it some other way by going through menus or something. Instead, I can just on the same page draw what I want, and it comes up. To get this equation on the graph, I draw a line from the equation to the graph, and just like drag and drop. Now I've got this equation on the graph.
How are you changing the scale of the graph?
He'll get to it.
Yeah, you can't, unfortunately, I can't see my hand, but I'm just touching it. So this blue title bar, if I grab it, if I click on it and drag, I move the graph. If I touch with one finger on the graph, it pans it. If I use 2 fingers, it's like
iPhone.
the touch interfaces for pictures on smartphones and stuff. You can zoom in and out.
Thanks.
Okay. So now let's say I say y equals x squared plus b, and I want to set up just a before and after type other graph as well. And if I, see, if I write b equals 3, I think I showed this earlier without talking about it. Any math that's on the page will be joined as you'd expect. So when I say b equals 3, it plugs it into the lower equation, and then the graph updates as well. I can shrink, I'm not going to explain how I do all this, but I can shrink the ink if I'm starting to run out of space. Scrolling's nice, but sometimes you want to see everything, and when you scroll, you lose context. So that's a way to sort of shrink the content of the page and fit more on the same view. And now the B is blue down here on the bottom right, which means it's like a hyperlink, but if I click on it, something's going to happen. In this case, it turns into a slider. So now I can vary the values of B and have, talk about as B is getting bigger, what's happening. Okay. Let's see. Another thing. Yeah, if you click the table button, there's a table of values. So we have various views, and this is one of the big things with FluidMath. There are important representations, and part of what students are trying to learn is when when to use different representations, or when they can help you find an answer. Or and in this case, we're seeing algebraic, graphical, and numerical all on the same page, side by side, without having to switch devices or take time to retype in something you'd already set up as the context of the problem. It's just all right there.
And you can put in more than one variable into that quadratic. You could have a couple sliders, like a coefficient of x squared, correct?
Yep. Yeah. So here's a different form where I could do this. X minus h squared and equals a. Let's try that. Okay. So and just to show you, you may wonder, well, what if it doesn't recognize my handwriting? There's usually two situations where that happens. One is somebody wrote messy, and sometimes the person would have trouble reading it. And the other is we didn't recognize it well. Our goal is to recognize it well. But if there is a mistake, because of this, I haven't even talked about it, but there's a scratch out gesture. It lets you just erase whatever strokes are under it. You kind of do a little bit of a vigorous back and forth over some ink, and it will go away. And that's useful in this case to correct a misrecognition, or when a student raises their hand and says, well, what if that, exactly like you did, what if it was a different equation or something like that?
Thanks.
So just to finish this, if I create sliders for all this and drag that on the graph, now K is going to, is going to transform the equation up and down. This slider H is going to translate it left and right, and A will change the shape.
Excellent, thanks.
Okay, so I'm going to move on. There's more I can show you with that, but like we can put up coordinate pairs and help illustrate, well, what is the meaning of A? It affects this. You can start to predict what the value of A would have on the graph and that kind of thing. So let me show you equivalence. This is maybe a little before younger math, but maybe some kids would benefit from it, so I want to show it to you. If you have an expression like this, x minus 3, and you ask kids to simplify it, it's hard for a lot of them to get their head around exactly how it should work, and they'll probably write something like this, 2x minus 6. So I have a mode on here, under options, we have a mode called equivalence highlighting, or highlight equivalence. So every expression on the page, instead of just having this yellow, the yellow sort of tells you what which ink on the page the computer thinks is one expression. So now, instead of it being yellow, it will change colors based on whether it's equivalent to anything else on the page. So because this second expression I wrote is a different color, me as a student or whoever's operating it knows these are not equivalent. And if my goal was to simplify or to solve, I've made a mistake. It's not telling me what the mistake was. And we've had some discussions about giving hints or doing something. But I just know I should stop and check my work and think a little more before I go on 4 more steps and end up at the wrong answer. So if I correct that, it should be, right? Hold on a second. We start going over. Minus 2 times x minus 6. And I had written minus 2x minus 12. And if I change that to be correctable, it'll match. So
Thanks.
I need to show you this. I'm going to show you two more things. How are we doing for time? We're
We got
doing good.
a little bit of time. Yep, keep going.
Okay, so I like mathematics. I'm assuming you all like mathematics, but for some kids, mathematics is hard. And one reason we've heard or talked about is it's abstract. It's like, when am I ever going to use this? How does this relate to anything? So a different way to come at. All right, I can. It stops working, but I can do it with my finger on it. Another way to come at problems is to start with a real world problem and then go to the mathematics. So I'm going to show you how we can draw. So I've changed the mode to a draw mode, and I can set up a problem, a real world problem, like maybe two objects that are moving. So in this case, I'm not going to talk about the mathematics. I'll set up some math, but I'm going to have two cars that are moving at different speeds, and I'm going to ask you a question about them. And you need to find the answer. And instead of just saying it, I'm going to show it to you. So see if I get this right. Okay, so those equations are just describing the motion, but it doesn't, that's not what I want to talk about first. I'm going to display this animation. And my drawing will come to light and take on the properties of the equation. So instead of just saying there's two cars moving, I can show two cars moving. So I drew this picture of two cars, set up some conditions around it, and then with this animation mode, I can associate the math with the objects and say play, and we see it play out. So we'll usually say something more like, Johnny got his license and he accidentally was going too fast on the highway, and the police car clocked him. And how long from when the police car started at 0 miles an hour till how long will it take until the police car catches up? So that's a model, or this is a model of that scenario.
Excellent. Thanks.
Okay, so now that's graspable by many kids, and we can start to use the tools I've already showed you to investigate the problem. So let's graph these two equations. So there's another shortcut to graphing, which is to draw a line that starts inside one and ends up on the side. But I have a graph of these two equations, and instead of them just being some numbers and plots and lines and stuff, they relate to what we're seeing. So what do you see in the graph? There's eventually someone will say, well, they intersect, and one's straight, one's curved, and this is reflecting the constant velocity versus constant acceleration. And if I come into draw mode, I can maybe highlight these intersection points and talk about what it means. What do they mean at those 2 points, and what is the axis, and what is the horizontal axis, and what is time? What time do these cross, and what does it mean when they cross? So eventually we might say, well, that's when they're caught up. So we think it's going to catch up at 8 seconds. If I tap on my slider here, I can change the end time to 8 and run it again and test my hypothesis. Alright, so when I run it this time, with the end time being 8 instead of 10 seconds, it looks like that's about where the cars meet up. And this is a good time to say, well, visually isn't good enough for mathematics. We want to know exactly when they caught up. And see, we can do that by substituting values. So if I say t is equal to 8, what is the value of a sub x, and what is the value of b sub x? Yeah, now I can see it's exactly 640. That's the distance these two cars have traveled at 8 seconds. Okay.
Thanks.
Wow.
Moving on, last thing I'm going to show you, and then we can do some Q&A. Does anyone know Neil Salva? He's a teacher at Deerfield.
Yeah.
And then you're here. He's been using FluidMath for many, many years. He had, when tablet PCs first
Thanks a lot. But yeah.
I was curious, the applications to Algebra 1 and Algebra 2 and pre-calculus are pretty obvious. Could you show us some applications for geometry and trigonometry and calculus?
Yes, geometry is limited because we don't work with figures directly yet.
So
We have
you're not at the point where you can
absolutely have an
use
idea for
sketch
fluid
method.
geometry where you could see if you could imagine, instead of algebraic expressions coming to life, it would be geometric figures with annotations of angles and lengths and other things coming to life. But it doesn't exist yet, so I'm sorry.
How about trigonometry?
But it works. But it won't probably be. I can't say when it's really going to be ready for use. So.
Okay. Could you say anything about trigonometry and calculus?
Yeah. So trigonometry is we have support trigonometric functions. We have let me see if I can bring this up. We have another resource. We have 100 plus Common Core aligned lessons and activities for grade 7 through high school. So we can make this page available to you, but you can drill down. So you pick a grade or a topic, and you can drill down. So even though I said we don't have much with geometry, there's certainly some activities that lend themselves to what we do. So what you can do is drill down and see a standard and then a description of what it is. And then on the right column here, each link is a document that has an activity that could be used. So was calculus another question?
Yeah.
Yeah. And
Yeah.
trigonometry.
So we have let's see where we are here. Okay. Yeah. We can recognize there's things people ask for and things we don't quite have yet. Like a lot of people will ask about trying to illustrate integration or showing area under the curve. We don't have that yet, but you can, as you can see, we have a math engine that supports integration and doing calculations. I drew this a little big, so it's off the screen.
Will it calculate a definite integral yet?
Calculate what?
A definite
A
integral.
definite integral?
Yeah. So like X. Let me just show you. I think you're it. Here we go. So this is just calculating indefinite, right?
Yeah.
And then 0 to 1. You can write. You can make it definite.
Wow.
Why are we here?
That's pretty cool.
So even though we don't illustrate, you can
Awesome.
certainly do the things like illustrate yourself by marking up, the meaning. Oops, sorry.
So he's clicking up above. The little record button is blocking right there, but there's pen tools up above that the record button is blocking right now.
For some reason the ink isn't sticking, but it should be that you can write here and it'll stay, but you could fill in that area and say this is what we're.
Cool.
What in effect is happening? We're summing this area.
We have about 1 more minute. Any other questions people have?
Does the interface work just as well with other kinds of functions besides polynomial functions? We've seen a lot of polynomial functions. What about like trig functions or log functions or?
Yeah. So we support trigonometry. You can do parametric plots. You can do polar plots. What was it? Someone do an interesting. It was part of this x equals pi. It was interesting. That's gonna work.
Can you plot with polar axes? Can you change the axes themselves to be polar?
Let's see. Well, okay, so you can change the axis style. I don't think currently, for no particularly good reason, we don't show axes drawn as a polar, like angle and radius. But you can change the axis style in terms of radians and degrees. So
Cool. Thank you.
Yeah.
Any last question?
Maybe one of the other takeaways, I mean, this isn't needed really for the concepts, but we move pretty quickly. If you're using a Microsoft product and and you say, hey, could you put in polar background, axes that make sense of that, we wouldn't even know who to write to, probably. And who knows if it would happen. But we're in Massachusetts, we're down the road from y'all, and we try to respond because we recognize that every request, isn't just, hey, would you mind doing this? It would be neat. It's usually really critical because you know that it would help the student, see or learn better. So
Excellent.
be very responsive.
Well, thank you very much for joining us, Andrew. We'll definitely be in contact with more questions, and thanks again for joining us.
Thank you.
All right.
Thank you.